In this video, we're going to take a look at the SR Planogram Automation Solution. The Planogram Automation Solution is a sophisticated tool for producing store-specific planograms that accurately reflect visual merchandising rules that have been defined upstream in the process and balance the inventory on the shelf to correctly meet the needs of the individual stores. The planograms produced by the solution will not only be efficient in terms of the inventory that they represent on shelf, but will also accurately reflect the decisions that have been made upstream in the process, ensuring the right products for the customers who shop in that store are available on the shelf, merchandised in the right place where the customer expects to be able to find them. To start the process, we're going to start a step back in the shelf planning solution. So here's the planogram that I've created. At the end of the clustering and assortment optimization process, I've applied the visual merchandising rules and I've produced a planogram that I'm happy with. Let's take a quick look at a couple of the visual merchandising principles that I've applied here. First of all, you can see that the products are merchandised in coolers in the cold vault section of the store. And you can see that, broadly speaking, the products are placed in blocks aligned to the signage above each cooler. Let's take another look at some of the visual merchandising rules I've applied here. Within each block, there's actually a brand blocking, and I can see this by changing the highlight to brand. Here you can see that, broadly speaking, the brands are blocked together. Furthermore, the brands tend to serpentine between the shelves, and this is one of the rules that we want to maintain when we create the store-specific planograms. These visual aspects of the planogram are quite important for the customer when he's shopping the category. So we're now going to move from the shelf planning solution to the planogram automation solution. And you can see I've got the planogram I was working on. I've also got the other planograms that we didn't look at, but we've actually got a set of planograms that represent all the different stores in our estate. But for the purposes of this video, we're going to focus on the budget cluster of stores and the planogram that represents those stores. So there's a number of different ways we can define the visual merchandising rules on the planogram. The first and most obvious rule that we want to define is the blocking rule, and we know that the products are principally sort of blocked based on the signage at the top here. And we could either sort of create manual blocks, so you can sort of freehand select which products go into a block, or you can actually use product attributes to create those blocks. So in this case, I'm going to use subcategory, and you can see the system has automatically created blocks on the planogram based on the subcategory information that's attributed to each product. For each of the blocks, we then have a number of different rules that we can define. For example, we can define exactly how much space, either as a percentage or in absolute terms, a block should be allowed to occupy. Typically, percentages are used if you want blocks to sort of flex between the different planogram sizes, because remember that the planograms that we create from this model planogram may have a fewer number of shelves or a fewer number of bays, or indeed a larger number of shelves or larger number of bays. So this one planogram can actually be used to make many different set sizes to represent different stores. We can also set rules, for example, around the squareness of blocks. So do blocks have to be square, or are they allowed to have ragged edges? We can also set rules, for example, of the minimum number of products that must be within each block. So it might be that you want the system to respect the assortment that is within the block and not to drop any assortment in a block. And in that case, you can set a minimum number of SKUs. So all the system will be able to work with then as it resizes the block is the number of facings. As well as rules around the blocks themselves, we have a number of other rules around placement, inventory, assortment, and item family. I won't work through all of these rules in this demonstration, but just to describe a few of them, starting with placement rules. Placement rules describe how products are allowed to move from one shelf to another. and how products are allowed to be oriented. So, for example, if you set the can move property of a product, this allows it to move up and down a specified number of shelves. You may also set a multi-position property, which means an item may be placed in multiple positions. And you can also specify not just the default orientation of a product, but alternate orientations. So, for example, if a product is normally merchandised sort of front bottom, but actually you would allow the product to be placed on its side, you could set that as an alternate orientation, and then the system may choose to use that if it can optimize the planogram better using that alternate orientation. We can specify the full inventory rules, such as, for example, case rules, facings rules, and effectively balancing all of those with the days of supply to get the right capacity of the product to the store. We also have assortment rules, so that is defining which items are absolutely mandatory and must be on the planogram, and which items we could potentially drop if we were unable to place all the items in the assortment. And then we have item family rules. These are actually inherited from earlier on in the process. So if you've defined these during your assortment optimization, these rules will come into play. And they're things like companion items, so a shampoo and conditioner, for example, or stocking a minimum representation of a certain brand or supplier, for example. So now we've defined all of the rules for our template planogram, what we want to do is we want to use this template planogram to create our store-specific planograms. And the idea is that the store-specific planograms should represent the visual merchandising rules that we've defined on our template planogram, even if they are different in layout and structure to that template planogram. And they should also balance the inventory to the store-specific demands so that we have an efficient planogram that isn't going to cause out of stocks. So on the left-hand side here, we have a number of different templates I've been working on. Generally, the more templates you make, the better results you'll drive, but obviously it's a balance between not putting too much work into templates and actually having the system do most of the work for you. So let's take our template here that we've been working on. If we just double click it, it comes onto the right hand side, and you can see that this planogram represents a number of different stores here. What I want to do now is I want to actually run this template planogram to create the store-specific planograms. I'm actually going to let this play through in real time so you can see how long the system takes to generate a planogram. Because this is a cloud-based system, we can actually scale up and scale down the processing sort of capabilities of the environments to meet the performance targets. But you can see even in this example here, in this demonstration, the planograms are generating relatively quickly. We're averaging probably a planogram every sort of few seconds. So even with hundreds or thousands of planograms to do, it's not a huge processing task for the solution. Okay, so now that we've generated the planograms, we want to go and review the results. And of course, the challenge with reviewing the results is you're potentially going to have thousands of planograms to look at. The way the solution can help you here is through a sort of scoring mechanism and a threshold for auto approval. So you can see all the planograms that have been generated here get a different score against them. And that's actually a composite score that's made up of 3 individual metrics that the planogram is assessed upon. So first of all, it's assessed upon the actual assortment that's placed. So did we meet the objectives of the assortment? Secondly, the visual merchandising rules. And thirdly, the efficiency of the planogram from an inventory point of view. We typically set a scoring threshold above which the planograms would automatically be approved. So let's imagine this example, that threshold set at 75%. You could see most of the planograms would be approved with a couple of exceptions. Okay, so here I just wanted to have a look at the output, and what I've done is I've flicked back to the shelf planning module rather than the planogram automation module. And this is the nice thing about this system, is it's all interconnected. So the planograms we make in planogram automation, we can view the results straight away and back in the shelf planning module. And what I've done is I've used the nice sort of side-by-side comparison we have in the shelf planning module here. To look at the template planogram on the left. So this was the original planogram that I started with, and the planogram that we've made for store 788 based on this template planogram on the right hand side. And I've just applied the shading based on the brand blocking just to understand were the rules respected. And you can see, for example, that serpentine rule we had earlier, sort of with the brands flowing from one shelf to the other, is respected quite nicely. You can also see some of the key differences in the planogram. So if you look, for example, at this shelf on the top right here, we've got quite different capacities of the two products that are on the model planogram versus the store planogram. So what's happening here is the system is correctly understanding the sort of the local behavior of that store, and it's matching the capacity to that behavior and that demand profile, and generating a planogram that's going to be efficient for that store, as well as a planogram that follows the visual merchandising principles that we've defined previously. Just to finish off, I'm going to talk about some of the other options in the workflow. We have an analysis section, which once you've created the planograms, allows you to analyze from a number of different perspectives, sort of understanding the distribution levels of different products, how many stores those products are in, understanding share of space across all those planograms, which stores items are authorized in and which stores items aren't authorized in. So these different analyses help you to get a holistic picture of the performance of this set of planograms that has been created by the planogram automation solution. And then the final step in the process is actually to publish the planograms to store. So once you're satisfied with the set of planograms, you can effectively make those planograms available to the individual stores, and then there can either be sort of a further workflow process where the store manager has discretion to change parts of the planogram, or that may be the final recommendation from head office at that point, and the store may then implement the proposed planogram. As we click on the Publish button, what the system does is it actually writes all the planogram information back to the database. And I'm showing you here in this Excel file the type of information that is written. So for every product, we can see its position on the shelf and on the planogram, its absolute position in XY terms, the number of facings, and also other related metrics such as the product dimensions and the capacity on the shelf. This information is then passed to our Shelf Intelligence solution, and we'll now take a look how we actually use that Shelf Intelligence solution in store to check that the store is complying with the planogram that we've published for it. So here we are in store with our Shelf Intelligence solution, and notice that we're in a live shopping environment. We have customers walking around the store, and we're starting to capture the shelf. Using the device, we capture the shelf a photo at a time. It doesn't matter exactly how much of the fixture we include in each photo. As long as we overlap each photo, the system will correctly join these together when analysing the shelf. All that remains now is to capture the rest of the shelf. Now that we've captured the entire fixture, through the Shelf Intelligence solution, we can analyse the results. Let's click on a capture and see what we've found out. Here we can see on the left-hand side we have the original capture image, and on the right-hand side we have the Shelf Intelligence. We can click on an item to see what intelligence the system has derived. We can see that this product is described as a wondering product. This Pepperidge Farm product is okay. Here's an invader. And here this cheese product is okay. We can then identify any products that the system hasn't been able to detect. We can also identify products that need moving have stock issues, or should be removed altogether. The beauty of this solution, of course, is that it is fully integrated with the category planning platform, so those planograms that we create in the cloud-based platform are instantly available to the stores, but also to the Shelf Intelligence solution, so we truly have an end-to-end connected system.